Hi everyone. So today we're going to look at parallel and perpendicular lines. So if you think back to last year, the year before, at some point you talked about parallel lines. Parallel lines early on in elementary school you learned are like a train track. I meant to do a pen here. They're like train tracks, right? They never touch. So on a graph, you'll oftentimes see parallel lines that are not exactly vertical like that, but you'll see them drawn sort of like on a diagonal, right? So if you think about y equals mx plus b, each one of those lines has an equation, and if they're parallel, then there's a relationship between the slopes. So try to think about what would the m values be for each of those lines if they're parallel. So if they're parallel, then m, or slopes, are equal. They're the same number. So for example, if I gave you a line y equals 3x minus 1, now I'm not looking at the graph of it, I'm just looking at the equation of it, and then I give you another line, y equals 3x plus 7, I could tell that those lines are parallel, that they're doing what that graph is doing there that I just showed you, by just noticing that they have the same number in the m position. They have the same slope. Okay, so this tells me that the lines are parallel. Lines are parallel because the slopes are equal. Okay, so another relationship between lines is that sometimes lines are perpendicular. Perpendicular means that they intersect, but they intersect in a special way to form a 90-degree angle, which we call a right angle, and we draw a little box to indicate that. So on a graph, you'll see it again sort of more diagonal looking. You'll see like one line going this way and another line going that way, like this, but they're intersecting again in a very special way, forming 90 degrees there. So again, we can tell if lines are perpendicular because there's a relationship between their slopes. Okay, let me just draw a dividing line here. So the slopes of perpendicular lines are opposite signs. One's positive, one's negative, and they are reciprocals of each other. If you think back, reciprocal means that you flip the numerator and denominator of a fraction. So perpendicular lines have slopes, again the m value, that are two things. Opposite signs, meaning one positive, one negative, and they are reciprocals, meaning that if it's a fraction, the numerator and denominator flip. Okay, so an example of that would be like the equation y equals, let's take 3x minus 1 again, and then the line that's perpendicular to it, I could tell it's perpendicular if the 3, the m, the slope, is flipped. So remember, 3 is really 3 over 1, so it becomes 1/3, and it has to become the opposite sign. So if it started as a positive, it becomes negative. Okay, and then the y-intercept, the b value, doesn't matter. So I'm just going to pick any number, like -5. Doesn't really matter. So again, if these numbers, the m position numbers, are opposite signs and reciprocals of each other, that tells me that the lines are perpendicular. Okay, those are two special relationships that that sometimes occur. If neither of those is true, if the lines are not perpendicular and they're not parallel, then we say that they're just intersecting. Intersecting lines means that they do this on a graph. They just basically cross, just kind of like the perpendicular do, but they don't cross at 90-degree angles. They just intersect at some random angle there. So this angle here it's not 90. Okay, and if that's true, then what you see in the equations is you'll just see that the m values are just different. They're not opposite signs and reciprocals, and they're not the same number. Okay, so you might see like y equals 3x minus 1, and you might see like y equals 2x plus 7. It doesn't really matter. Like this number for slope for m will be different, and it won't have this relationship of perpendicular where it's opposite signs and reciprocal, and it won't be the same number like in parallel lines. Okay, also be careful that sometimes you'll see examples like this on homework, on tests, like y equals 3x minus 1, and then y equals negative 3x, and then whatever, plus 2. And so these slope values are opposite signs, but they're not reciprocals. So because they're only opposite signs, that means that they are intersecting lines. Okay, they are not perpendicular. They're just intersecting. So on certain questions, like example 1, they'll ask you, tell whether the following lines are parallel, perpendicular, or intersecting. Sometimes the wording will be a little bit different. Sometimes the wording will say parallel, perpendicular, or neither. Neither meaning they're not parallel or perpendicular. Okay, and your strategy is convert to slope-intercept form. Convert each equation into y equals mx plus b so that you could look at their slopes. And then you can compare. If they're the same number, they're parallel. If they're opposite signs and reciprocals, they're perpendicular. If they're not either of those two, then they're neither or intersecting. Okay? So why don't you pause the video and take a minute to isolate y for each of these equations, and then you can check if you got them right. Okay, so for the first equation, I'm just going to copy it down where I have some space. I'm going to isolate y. So I subtract 4x. I have 2y equals negative 4x minus 8. I divide everything by 2. I have y equals negative 2x minus 4. So I'm looking at the m value, the slope, negative 2. Then I go to the second equation. I do the same thing. 6y minus 6 equals 3x. I'm going to add 6 to both sides. I have 6y equals 3x plus 6, divide everything by 6, and y equals, remember 3 out of 6 is 1/2 x, and then 6 divided by 6, remember, is 1. So I have a slope of 1/2. I compare these. They are opposite signs, and they are reciprocals of each other. 2 over 1 flips to become 1 over 2. That tells me that the lines are perpendicular. Okay, I can only do this after I've isolated y. I'm going to do another one. Example 2. Pause the video and you try this by yourself. Okay, so we're going to isolate y. The first equation, 3y plus 27 equals x. I am going to subtract 27 first. I have 3y equals x minus 27. I divide everything by 3. I have y equals, remember there's an invisible 1 here, so this is 1/3 x, and then 27 divided by 3, negative 9. That's the first equation. Again, I'm looking at the m value, the slope. The second equation is going to become, I have 3x minus 9y equals negative 18. I'm going to subtract 3x. I have negative 9y equals negative 3x minus 18. Divide by negative 9. So I have positive, negative divided by negative is a positive, and that's 3 out of 9, which is 1/3 x, and 18 divided by 9 is positive 2. So I'm looking at a slope of 1/3. They are the same number. That tells me that they are parallel. I'm sticking an E in there. Okay, I'm going to stop the video here. There's going to be a second video, because if it's too long, it doesn't post. And we're going to do just 1 or 2 more examples.